Hey everyone, it's Alisa. I have a statistics question for you. It could be either step 1 or step 2 material. Now go ahead and pause this video, answer this question, and come back with me and we'll go through it together. The height of a Norwegian female adult is expected to follow a normal distribution, with a typical female adult having an above average height of 69 inches with a standard deviation of 0.1 inches. An investigator has been informed about a small population living in the mountains greater than 10,000 feet above sea level, in which a lower mean height has been reported. The investigator plans to sample 30 female residents to test the claim that the heights in this town differ significantly from the national average based on the heights assumed to be normally distributed. The significance level is set at 10%, and the probability of a type 2 error is 15%. Based on this information, which of the following is the power of the proposed study? Is it 0.05, 0.1, 0.15, 0.85, or 0.9? Now, if you're like me and you see this kind of question, you automatically start constructing one of those tables in your head and you get all nervous and you worry. Well, don't. The first thing you should do is you want to know what they're asking for. They were asking for power, and they're giving you a significance level, and they're giving you a type 2 error. Now, actually, that's all you need to know to immediately answer this question. So, power is the probability that a study will detect a true difference. In other words, reject the null hypothesis when the alternative hypothesis is true. So, I'm bringing this chart back. It's from Boards and Beyond, which has fabulous information for step 1. And let's review that if a study finding is positive and the reality is positive, that's called true positive. But actually, that's also power. And power is 1 minus beta. Now, that's one important thing to remember. Power is 1 minus beta. If a study finding is positive but the reality is negative, that's called a false positive. That is a type 1 error. If a study finding is negative but the reality is positive, that is a false negative. That is a type 2 error. That's also called beta. That's our second really important piece of information. And finally, if a study finding is negative and the reality is negative, that is a true negative. Okay, what we care about is this column right here. We care about the reality. So let me remind you, power is 1 minus beta. And beta is the same thing as a false negative or a type 2 error. So what is our question asking? I already forgotten at this point, so let's go back and review. We're wondering about the power of the study. And here's that word type 2 error. So if our type 2 error is 15%, keep that in mind, so 0.15, that's our type 2 error. We know that the type 2 error is the same as beta. And what is power? Power is 1 minus beta. See where I'm going? So 1 minus 0.15 gives us 0.85. Which answer is that? Right here. Excuse me. But let's go through the rest of the answers just for fun. So 0.05. This is the typical significance level of most epidemiological studies, but the alpha in this case was 0.1, excuse me. So we already have the significance level, so this isn't going to be it. 0.1 is what we know is the significance level. This is the probability of rejecting the null hypothesis. The probability of rejecting the null hypothesis when the alternative is true. Again, this is our alpha. This is not going to be what we're looking for in power. So 1.15 is our type 2 error, aka our beta. That's what we were given. So in this study, our beta is 15%. But remember, power is 1 minus beta. Now here's our answer. So the power is the probability of correctly rejecting the null hypothesis. And so power is 1 minus beta. Beta is type 2 error. I've repeated myself enough, but you know, Power is 1 minus 0.15, which is 85%. And then finally, the 0.9 is the confidence level of the study. So confidence is 1 minus alpha. Alpha is the significance level. And here our confidence level is 90%. Now, it's important. Sometimes you'll get a question and it says, what does the p-value mean? And everyone starts to panic and they're confused. All the p-value is, all the alpha is the confidence. So 1 minus 0.05 means we are 95% confident that, we're correct. Or if the alpha is 0.1, then we are 90% confident that we are correct. And the lower alpha is, the lower our p-value is, the more confident we are that we are correct. So power equals 1 minus beta. The more we decrease beta, the more we decrease type 2 error, the more we increase power. This is a fabulous chart to memorize. Stare at it, love it, learn it, make it your phone background. Just really know this chart. It'll help you a lot in statistics. Thank you so much for doing this question with me, and we'll see you next week.